So now let's talk about observational studies and study and designed experiment. Okay, so in an observational study, it's like I observe smokers. I'm going back to that. So I do not perform any intervention. I do not tell them what to do. I would not tell them how many cigarettes to or force them to smoke per day, so I can study my response variable. So this is the explanatory and this is the response. I do not interfere. I just watch. At the end of the day, I give them a call. How many did you smoke today? Check. At the end of the next day, how many? So this is an observational study. I do not attempt to influence the value of any variable. So no attempt to influence the value of the response and the value of the explanatory variables. I just observe. Nothing else. If I only observe, I can only conclude, this is very important, I can only conclude association, not causation. If I don't interfere as a researcher in any way, shape, or form, I can never say, listen, my study says that smoking causes lung cancer. I cannot. If I observe a relationship between the response variable, which is lung cancer, and the explanatory, the number of cigarettes smoked per day, if I see a relation, I can only say it's an association. But I could never, in an observational study, I could never say that lung cancer is definitely caused by the number of cigarettes smoked per day. Association, I can say, yeah, I see a relationship, an association. They are associated. There is a relationship between these two. But I cannot never say that lung cancer is produced by the number of cigarettes per day, or the number of by smoking. Smoking, I cannot conclude that smoking produces lung cancer. Okay, what about a designed experiment? Here I use so researcher intentionally changes the explanatory variable to study the result of the response. Okay, and records the value of the response. Variable or variables. Now here I can conclude causation. So if the study shows, I can say, if it's based on results, If it's not based on results, I cannot say anything. But assuming that I get in the design experiment, it says yes, then I can call that clearly on, I say, the response variable, which is the lung cancer, is caused by smoking. But in an observational study, I cannot do that. Two pieces of information next. One is called confounding. And we'll talk about that for a minute. And then the other one, lurking variable. And we can start working on 1.2 after this. Okay, what is confounding? In a study, confounding occurs when the effects of two or more variables, when the effects of two or more explanatory. Remember, explanatory is the X variable, the independent variable. Variables are not separated. So the result here is that the conclusion may not be accurate. So conclusion may not be accurate. So, for example, I may study older people blood pressure. Okay, so that's another study that I could be interested in. So let's say 70 and 90 years of age. And my target is blood pressure. And let's say I look to see just a relationship between age versus blood pressure. Oops. But what I forgot is health, status. I did not consider it, but that's very important. So I cannot say that the blood pressure is high or low based on age if I don't look at the health status. Maybe that person is taking medication for blood pressure for different reasons. So that's a confounding explanatory variable of the blood pressure, but I didn't take it into account in the study. I didn't look at it. So now my results cannot mean much to you. If I say, oh, blood pressure is related to age, at 70 is lower, at 90 is higher, or vice versa. No, I can't, because I did not look at the health status. I didn't look whether they are taking medication for lowering blood pressure. I didn't look at if they do any activity level. I didn't. So my study doesn't really mean much, because this can be affected by this, and I did not take them into account. Okay. So now let's finally talk about a lurking variable. Any questions? Any questions?
No.
Okay. So a lurking variable is also an explanatory. An explanatory variable that affects a response variable. In the study. So let's see how we differentiate, and let's look at the work. We have a few minutes. Let's at least get it started. I'm sharing my screen. Okay. So don't forget about 1.2, the interactive assignment. And let's start with 1.2 now. Let's see what we can do. Good. Observational study versus designed experiment. In an observational study, researchers simply observe characteristics and take measurements, as in a sample survey. In an observational study, researchers impose treatments. No, we're not touching anything or anybody. In an observational study, researchers look at all the members of the group being studied. No, we cannot get to the population. Even if I call it an observational study, I cannot get to 360 million people unless it's a census. So, yes, they simply observe. They don't do anything else. Good. There are only 8 questions in this one. Let's see what else.
Five.
Okay, let's look at 5. Very good. Oh, sorry. Okay, so there is part B here. Choose the correct answer below. In a design experiment, researchers look at all the numbers of the group being studied. Oh, all the members, I'm sorry. What am I looking at? Researchers look at all the members of the group being studied. In a designed experiment, researchers simply observe. No, it's not simply observe. In a design experiment, researchers impose treatments and controls and then observe characteristics. And I want to stop sharing for a second, and I want to add this in here. It's very important. Please add it in. Yes, it is true. Impose treatments, so-called. It's not a treatment. It's we're giving a medicine to a group and not to another. So to compare treatments, so to speak, we call them treatments. Impose treatments and have control group. Control groups or group. Please add it in. Impose so-called treatments. The researchers impose treatments and have control groups. Okay, I'm sharing again. So yes, and controls and then observe characteristics and take measurements. Yes, that is the key. Impose treatments and have controls in a designed experiment. Good. Moving on.
6.
Okay, let's take a look at 6. Explain what is meant by confounding. Good. And what is a lurking variable? Good. Okay. What is a lurking variable? Choose the correct answer below. A lurking variable is a quantitative variable. No. It can be anything. A lurking variable is a response variable. Yes. Let's read. That has an infinite number of possible values that are not countable. What?
Okay. I thought you said it was an explanatory variable.
Oh, you said explanatory variable. Yes. Sorry. Yes, I wasn't looking. I wasn't thinking carefully. Yes, absolutely. A lurking variable is an explanatory variable that was not considered in a study, but that affects the value of the response variable in the study. In addition, lurking variables are typically related to explanatory variables in the study. Yes. It can be quantitative, it can be qualitative. It doesn't have it's not a response variable. Absolutely not. It's not the y variable. It's the x. It's the independent, and it can be any type. Good. We have 2 more minutes, so let's choose.
Question 8.
8 it is. Very good. Oh. So what do I do? Why is it saying to try again?
You didn't hit complete when you put the answer in. So now you did. Now you should be able to go to a different answer or a different question.
Okay. Oh, good. Select the correct choice that completes the sentence below. Observational studies can reveal only association, whereas designed experiments can help establish
Causation.
Thank you very much. That's it. That's a big difference between the two. Awesome. Thank you. Who said that?
Me, Emma.
Emma, thank you.
You're welcome.
Let's do number 4.
Okay, last one, 4. And before I forget, it's a holiday weekend. Don't drink and drive. Determine whether the study depicts an observational study or an experiment. Second grade students are randomly divided into 2 groups. One group is taught English using traditional techniques. The other, English using a reform method. After 1 year, each group is given an achievement test to compare its proficiency with that of the other group. Before we read anything, is it an observational study or a designed experiment?
It's an experiment.
Absolutely. Groups and control, of course. So it's a waste of time to read B and C. The study is an experiment because the researchers control one variable to determine the effect of the response variable. The study is an experiment because the study examines individually in a sample but does not try to influence. No. Yes. The study is an experiment because the researchers control one variable, which is the treatment, to determine the effect of the proficiency by testing them of the response variable. Well done. Thank you very much for coming today. You do have to finish 1.1 and 1.2, the interactive assignment and homework between now and a week from today.
Thank you.
Thank you very much.